Hello, students.
So you want to charge your electric car using nothing but the power of the sun, right? Sounds simple, but it's actually not. There's some seriously smart tech working behind the scenes to make it all happen. Today, we're going to pull back the curtain and see exactly how it works. Let's dive in. Okay, so electric cars are taking over, which is awesome. But here's the elephant in the room. Our power grids just weren't built for millions of cars plugging in all at once. It's a huge logistical problem. So if the future is electric, how in the world are we going to power it all? Well, we're basically at a fork in the road. We can keep relying on the traditional grid, which, is often fossil-fueled and gets super stressed out during peak hours, or we can get smarter. We can go with integrated solar charging. And look, this is about way more than just being green. It's about creating a charging system that's tough, reliable, and doesn't have to depend on a fragile grid. So what does this smart solution actually look like? Just imagine a self-contained mini power plant right there at the parking spot. It's grabbing sunlight, storing it up, and feeding it directly to your car right when you need it. Let's break down how this whole thing comes together. A smart solar charging station is really a team of 5 crucial players working together. First up, you've got your solar panels, the PV array. That's your power plant. Then there's the battery system, which is basically your energy bank. You've got power converters, which act like universal translators for electricity. Of course, you need a smart control system, the brain of the operation. And yeah, you still have a grid connection, but it's just there for backup. All right, so using the sun's energy sounds easy enough, but here's where things get really tricky. The sun is an unbelievably powerful source of energy, but it is anything but steady. I mean, think about it. A cloud drifts by, the temperature drops, the sun gets lower in the sky, and boom, your power output just dives. It's constantly fluctuating. So the real engineering puzzle is, how do you squeeze every last drop of power out of a source that's always changing its mind? The answer is this incredible piece of software called a Maximum Power Point Tracking Controller, or MPPT for short. The best way to think about it is like an expert sailor who's constantly trimming the sails to catch every tiny gust of wind. This algorithm's entire mission in life is to constantly fine-tune the solar panels to stay right in that sweet spot of maximum power generation. So how does it actually do that? Well, the most common way is called perturb and observe. The brain makes one tiny little adjustment and asks, did that help? Did I get more power? If the answer is yes, it does it again. If the answer is no, it immediately goes back the other way. And it does this thousands of times every single second. It's relentlessly hunting for that peak power point. And the difference this makes? It's huge. Just look at this. A regular, untuned solar panel might be leaving 30% of its potential energy on the table. But with an MPPT brain constantly optimizing things, you get pretty darn close to 100% of what's possible. That's a massive efficiency gain that turns wasted sunlight into real miles for your car. Okay, so we've wrung every possible watt out of the sun. Now what do we do with it? This is where the battery and converters come in. They're like the air traffic controllers for the whole system, directing all that energy exactly where it needs to go. Right, the battery. This is the system's secret weapon. Its energy piggy bank. Any extra power the panels generate on a super sunny day gets stored right here. And that means the charging station isn't useless when it's cloudy or dark. It can just tap into all that clean energy it saved up earlier. It's what makes the whole system reliable 24/7. So let's walk through how this smart brain juggles all these different scenarios. Sun's out? Great. Power goes straight from the panels to the car, with any extra juice topping off the battery. Cloudy day or nighttime? No problem. The battery steps in to charge the car. Battery getting low and the sun's not out? Okay, fine. As a last resort, it'll pull a little from the grid. And what if the whole grid goes down in a blackout? The station doesn't even flinch. It just keeps on charging, totally self-sufficient. But does this actually work for a real car that people drive every day? Absolutely. The whole system we're looking at is designed specifically around the needs of something like a Tesla Model Y, which gets about 3.82 miles for every kilowatt hour. The whole setup, panels, battery, software, it's all sized to meet that real-world demand. Okay, get this. This is a snapshot from a live simulation, and you've got to see these numbers. The solar array is cranking out 63 kilowatts of clean power. The grid? It's supplying 0 amps. It's not even being used. The big storage battery is sitting at a comfortable 70%, and it's feeding the car's battery, which started out nearly empty. This is the system in perfect off-grid harmony. This is so much bigger than just a cool way to charge a car. When you zoom out, what you're really looking at is a blueprint for a totally new kind of energy future. So when you put it all together, what's the big takeaway here? Every one of these smart stations we build takes pressure off our aging public utilities. It gives us charging we can count on, even when the power goes out. And it finally makes good on the promise of powering green cars with truly green energy. This isn't just a charger, it's the foundation for a much smarter, more resilient energy infrastructure. And that leaves us with one last, kind of mind-blowing thought. What if this technology wasn't just for a few showcase charging stations? What if every single EV charger in every mall, every office park, every apartment complex had its own solar and battery? Our parking lots wouldn't just be for parking anymore. They would become the power plants of the future, hiding in plain sight.